A pulse system of components only uses pulse information signals. This type of system usually employs logical components or, and, not, and pulse dynamic triggers. Pulse components have relatively simple circuits and low power consumption. The advantage of pulse components is the difficulties in the realization of high-capacity capacitors and transformers using integrated technology methods. Let us look at the schematic of a pulse diode component OR. It differs from a similar potential component as it has an RC oscillating circuit at the input. The parameters of the capacity and resistance are selected so that their product is much greater than the duration of the input information pulses. The signal at the output of the OR component appears if pulse is present at least in one of the inputs. The schematic of a pulse diode component AND also differs from that of similar potential component as it has an RC oscillating circuit at the input. The necessary conditions are as follows. Capacity multiplied by resistance must give a result much greater than the duration of the input information pulses. Resistance R1 must by far exceed resistance R2. The signal at the output and AND component appears if the pulses at all inputs coincide. The schematic of pulse component log4x2 is more complex. It uses a transformer on whose second coil voltage is induced. If there is a pulse at input x2, this voltage compensates for the log bias of plus UCM. Due to this, diode VD2 is opened and the output of the component in practice connects to the earth potential. That is, it provides the value of the logical zero. If there is no pulse at input x, the value of variable x1 repeats at the output. Artificial delay devices are often used in pulse circuits. They consist of T-type LC links. Delay devices have resistors to exclude interference at input and output.